Okay, so we've now seen several sources of market power, right? We've seen Cournot with a few firms, differentiation, collusion or conjectures, etc. But there's others, search frictions, heterogeneous costs, etc. And in fact, with complementarities, you can get even more than complete market power. This is related to what I was talking about with Lancelot. So for many purposes, the key thing that matters, though, is not the source of market power, but its level. And to summarize this level, it's useful to think about pecuniary versus real externalities. So I want to start by focusing on symmetric oligopoly. And in symmetric oligopoly, there are basically two types of effects of you changing your strategy, whether it's price or quantity or whatever. Saad, what are those two effects?
Would it be effect on the real price?
What?
The real price?
On the price.
Right.
And that gets multiplied by the quantity, right?
Right.
And then what's the second effect? Well, there's an effect on quantity, right? Which gets multiplied by the markup that you get, right? So the real effect is that there's a change in the quantity, which you multiply by the markup that people are earning, right? That's one effect on profits. How much the quantity changes multiplied by how much markup you earn on the quantity. So I'm going to denote that by M times DQ, right? And this is a real effect because it's not mediated through prices. It's mediated through actual actions that people take, actual quantities that are produced. On the other hand, there's an effect on the price multiplied by the quantity that people are selling, right? That's a pecuniary effect because it's purely mediated through prices. For every dollar the firms gain, the consumers lose, right? So what would a social planner want to achieve? Tyler?
Which effect they would prefer?
What would they want to, what is a social plan? Remember our Pigouvian lecture. We wanted to do what with all real effects, right?
Well, you don't want the real effects. You just want pecuniary.
You want to set them all equal to 0, right?
Yeah.
So they'd want to set this up here equal to 0,
Okay.
right? So on the other hand, what does a monopolist or a cartel want to do? Sing?
So they don't care about, they want to minimize the.
Well, they care about the total profits, right? And I said that these are the two types of effects on profits. So what are they going to want to do?
It doesn't make sense to maximize those externalities.
No, because these are the two effects, right? And you want to...
Oh, make it 0.
Yeah, you want to make this equal to 0, right? So the monopolist or a cartel would set the sum of the two effects equal to 0, because they care about both effects equally, right? So we can now define the conduct parameter to be equal to whatever the ratio of these two things is set equal to. So M times dq over negative q times dp, let's call that the conduct parameter. What will that be set equal to under perfect competition or if the social planner has their way? Franklin?
Well, under social planner, M dq equals 0, so that'd be 0?
Exactly. Under monopoly, what would that be equal to, Connor?
It would be equal to 1.
Yeah, because the monopolist wants this whole thing to be set equal to 0, right? And so more generally, we can use this as an index of how close we are going from monopoly to competition, because it measures how much we're internalizing the pecuniary relative to just the real effects. Yeah, Lancelot.
So can you go over why the reason for
Well, because these are the two effects that affect on profits, right? Anytime someone does something, it can affect the quantities and thereby change the markup times the quantity, or it can affect the prices and therefore affect the quantity times the prices. These effects are pecuniary and these are real, but the monopolist just cares about the total effect on profit, which is the sum of these two. Whereas the planner only wants to take into account the real effects. Does that make sense?
I just don't see why you want the total effect to be zero. Like, is that effect negative?
Because this is effect on profits, right?
Yeah.
So if we take the derivative of profits with respect to anything, right? Profits can be affected in two ways. We can change the quantities multiplied by the markup, or we can change. So the monopolist is always going to want the sum of those two things, the total effect on profits, to be equal to zero, because he wants to maximize profits.
It's like a first order condition.
Yeah. Okay. So more generally, we can just we have this ratio, which is the same as the markup divided by the quantity times the derivative of quantity with respect to price. Well, the derivative with quantity with respect to price, if we multiply that by price and divide it by quantity, we get the elasticity of demand, and then we get the markup over price here. So this is the Lerner index multiplied by the elasticity of demand. That is the conduct parameter. And really everything that we've been doing so far has just been a way of getting to what the value of that is going to be. And so this is like a general index that nests all the models of how competitive the market is. Okay. So Connor, can you relate this back to some of the models we've studied and talk about what the value of this parameter will be in different models?
So it would be theta equals 0 for perfect competition, and then it would be 1 for monopoly.
Yep.
And it would be 1 over n for Bertrand competition.
For Cornell.
Or for Cornell.
Yeah. And how about for differentiated products Bertrand? Do you remember that?
Is that when it can be negative?
No. Oh, it can be. It can be in an asymmetric model, but not in a symmetric model. Well, let's go through them. Connor, why don't you try to derive it for us in Cornell? Maybe, I don't know if you want to do that on the board or...
Left?
Yeah.
How is this index different from the other?
Because it's multiplied by the elasticity of demand.
Yeah, but does it measure something else? Or it's the same? Because I think it's like the same idea. The Lerner index just measures the deviation from the markups, right?
No, but the thing is, this is adjusted by the elasticity. The Lerner index, thus defined, will always be equal to 1 under monopoly, right? So it's how competitive you are given the demand in the industry, not like the overall level of the markup. Also, you'll see this idea can be generalized to asymmetric oligopoly in a way that the Lerner index can't be. Or not obviously.
Okay, so
Okay, so why don't you derive, remember what the first order condition was under Cornell? But that you're putting in conjectures, but we don't need conjectures. Yeah.
Oh, so it was just negative 1. The dqi, whichever.
Okay, so under Cornell, right, you have the p prime times the qi, right? Plus p, right?
Yeah.
Equals what?
Isn't it just nt?
Yeah. Okay, so now can you figure out what the value of this thing is under the Cornell model?
Yeah. So
Under symmetry, right?
under symmetry.
We're focused on a symmetric model right now.
So then Q would equal just n times Qi.
Yeah, exactly.
And so then theta would equal, so then M is going to be this.
Yep.
So then it's just going to be P prime Qi times dq over negative nq QI
Yeah?
times dp. So then the elasticity is,
You don't even need to go to elasticity. Look, you've got a p prime up there, and you've got dq dp there.
oh, so that just cancels.
Yeah.
Right?
And you've got qi on both the top and the bottom.
Well, so that negative shouldn't be there. Oh,
Yeah. Yeah, the reason is because your markup should have been negative this.
oh, okay.
Good. Nicely done, Connor. How about if we add, Jose? How about if we add in conjectures into this model? How is that going to change the value of theta?
Okay, so Q has to be multiplied by 1 plus the effect.
Yeah. And so what is that going to get us? What's going to happen to the value of theta?
Multiplied by the effect.
1 plus,
1 plus the effect.
yeah, exactly. So you're going to get 1 plus that effect, right? The conjectures effect. Under differentiated Bertrand, Arvid, do you think you can derive what happens under differentiated Bertrand? Do you remember our first order condition under differentiated Bertrand? We had a learner index version of it, right?
Yeah. Where you set the price.
So what did people set their price minus markup over price equals what in the differentiated Bertrand model?
They set equal to their effect on the others with the price minus their markups divided by price.
Well, it was the 1 over the elasticity of their residual demand, right? Not the elasticity of the total market demand, right? So that's going to be equal to negative of the quantity divided by the price times the partial derivative of their quantity with respect to their own price, not with respect to all the prices, right? So we can rewrite that as the quantity divided by price times the elasticity of total quantity with respect to total price times the ratio of that total derivative to the effect on their of the total market price on their individual quantity, where we multiply this by n because the other one was only the effect of their own individual price, and by symmetry, it's just n times. And so that gives us that theta is equal to the effect of increasing all prices on the total quantity divided by the effect of increasing all prices on just that own firm's quantity. We can then rearrange that and see that this is equal to 1 minus what's called the aggregate diversion ratio. The aggregate diversion ratio is if I sell one more unit of a good, how many of the units are taken away from other firms in the industry rather than coming from the outside good. So that's 1 plus n minus 1 times the ratio of how much my price affects other firms' prices to how much my price affects my own quantity. Yeah,
Can you
Tova.
just say what the aggregate diversion ratio is?
It's,
Again.
if I sell one more hamburger, how many of those come from other hamburger producers? Like who would have otherwise sold that hamburger to somebody? And how much comes just someone's going to buy a new hamburger that they wouldn't otherwise have bought? So that's like what fraction of my marginal sales come from other people. And you can write that out mathematically in a symmetric model as n minus 1 times the effect of my price on other people's quantities divided by the effect of my price on my quantity. Okay, so that's theta in the differentiated Bertrand model. Intuitively, if all my sales are coming from other things in the industry, then we're going to be competing very intensely because we're very close substitutes. If none of my sales are coming, then we're not going to be competing at all because I'm just monopolist and it doesn't matter what other people are doing with their prices because they're not taking away or giving any sales to me by how they change their prices. Okay. Now, this is not constant, typically. It's going to typically rise as prices rise. Why is that? Because if other firms' prices are higher, then they're going to tend to be less good substitutes for me. Because consumers, if other goods prices are higher, are going to tend to just say, I'm not going to buy anything, rather than buying from one of the firms in the other firms in the industry. So this theta will not tend to be constant as market conditions change. Okay. So as we saw before, many things can be summarized by incidence. And this, in turn, is going to be determined by this theta value and not by all of the other details of what determines theta that we were talking about earlier in the lecture. So, Robert, can you tell me how incidence is affected by theta and not by all the other details?
I'm not sure.
Okay, so if we take the derivative, remember incidence, right, is about how, say, producer surplus or consumer surplus is affected by a change in the tax, right? So imagine we now change tax. Well, what's that going to do? That's going to have effects through the changes in price and through the changes in quantity, right? So it's going to be equal to quantity times how much price changes minus the direct amount that the firms are forced to pay in terms of the tax, plus markup times the derivative of quantity with respect to price times how much price is affected by the tax. So we can remember that if we divide both of these by quantity, right, here we're going to get exactly the value of theta, right? And here we have the pass-through rate. And so we get that the amount that they're impacted is negative of the quantity times 1 minus theta times the pass-through rate. The effect on consumer surplus is still the negative of quantity times the pass-through rate. And so we get that incidence is now the pass-through divided by 1 minus theta times the pass-through. So remember that if theta is equal to 1 and we're under perfect competition, this becomes rho over 1 minus rho, which was the competitive pass-through, the competitive incidence. If we have monopoly, theta is equal to 1 and we just get the pass-through rate, which was the incidence under monopoly. But here this gives us a smooth mapping between those for any value of conduct. And we can do the same thing for the social incidence. Remember, that's the ratio of the effect of an exogenous quantity coming in the industry on the deadweight loss to its effect on the producer surplus. Robert, do you think you could do that? Try to derive that?
So the producer derived
Say the derivative of the producer surplus with respect to an exogenous quantity coming in to compete with the firm. You could try to do it on the board or...
So we start with that one there.
Well, so you have the producer surplus, and then you're trying to take the derivative of that with respect to this exogenous quantity coming into the industry.
And so what should we represent the exogenous quantity as?
So that's Q tilde, and you want to know how much... Remember we had this thing called the quantity pass-through before, which was how much does the quantity in equilibrium change when the exogenous quantity changes. So that's a number that you can use in this analysis.
I'm actually not sure.
Okay, I'll just go through it. So the first order condition now, right, is that price plus theta times the marginal surplus is equal to marginal cost. But remember, the exogenous quantity just reduces your inframarginal quantity, right? And so if we change the exogenous quantity, that's the same thing as changing marginal cost by theta times P prime, right? And so that will impact the price by the pass-through rate times P prime times theta, which is the same as impacting quantity by dividing that by P prime. And so you get that the change in the equilibrium quantity with respect to the exogenous quantity is theta times rho. Okay. Now, how is producer surplus impacted by a change in the exogenous quantity? Well, there's how price changes with respect to quantity times how quantity changes with respect to the exogenous quantity, which, as we just derived, was theta times rho. Then there's the markup and times however much quantity changes minus the exogenous quantity, which you're now somebody else is selling, and so you're not earning the markups on that. And so that gives you that producer surplus changes by negative m times 1 plus 1 minus theta times rho. How much does deadweight loss change? Well, it's just however much the markup is multiplied by how much the quantity changes, which again is theta times rho. And so we get that the social incidence is the ratio of theta times rho to 1 plus 1 minus theta times rho. And again, note that this is equal to 0 if theta is equal to 0, because there's no deadweight loss under competition. And under monopoly, this is just equal to rho. So we get back our old formulas. Okay. So both of these are sort of like an interpolation between the monopoly and the perfect competitive formulas using theta as the interpolation. And in fact, this can be done for theta greater than 1, as will be true when goods are complementary. And again, we can just get global incidence, the global ratio of consumer to producer surplus, or of deadweight loss to producer surplus, by integrating these. But now if theta is varying as the quantity changes, as it might do, then you're going to have to take averages, not just of the pass-through, but of pass-through times theta. Okay.
Yeah.
Yeah.
Was that the surprising result from the Dix and Stiglitz, where if you got like that, if you got that eta bigger than 1, so like you get the complements, and then you would want monopolist rather than competition?
Yeah, that's right. That's right.
Is that the intuition? Because like you want that monopolist to internalize
you want them to take theta down to 1,
Yeah.
which is better than having theta above 1. Because he's internalizing as we'll talk about in a later, we'll talk about in a few classes, if there's too many firms that are complementary with one another, they won't internalize the fact that if they lower their prices, it will benefit the other firms, because it will get more people to consume. Yeah. Okay. So, Luke, can you think of some natural comparative statics of the ratio of consumer surplus to producer surplus, or of deadweight loss to producer surplus based on changing theta that come out of these formulas?
Okay, so if we look at the deadweight loss,
That would be this.
yeah.
Deadweight loss of producer surplus.
So if we lower theta, that should in general reduce the deadweight loss.
Yeah? And do you see how that's happening here?
Yeah. Because the numerator gets smaller, denominator
Gets bigger.
So
Exactly.
that's
And how about the ratio of consumer to producer surplus? How is that going to be affected by changing theta?
So we look at the ratio, we're going to be looking traditionally that's just rho, but here it's not just rho. So producer surplus is going to be minus, minus, minus. It's going to be decreasing in theta.
Yeah.
Consumer surplus is going to be increasing in theta, I believe. Or I'm sorry.
It's constant.
Yeah.
Yeah, so the producer surplus is going, so the ratio is going to be, of consumer to producer surplus is going to be increasing is going to be decreasing in theta, which is what we think it should be, right? Because the more market power there is, the more that the firms rather than the consumers capture, right? Okay. So by a similar logic, we can relate the monopoly pass-through to the pass-through under for various values of theta. So, Robert, can you try to derive what the pass-through is going to look like here?
So in the monopoly case, the pass-through, didn't we say that was going to be, was it like theta over 1 minus rho theta?
No, under monopoly, there's no theta,
Oh,
right? So we derived in the monopoly class the pass-through under monopoly, right? And what was that related to? Do you remember?
It wasn't equal to the social surplus.
Well, yes, but in terms of like the primitives of demand and supply and the curvature of demand, do you remember how the pass-through was related to those things?
Was the elasticity of demand over supply?
Yeah, that was one of the terms. And then there was also an additional term. Do you remember that? It was related to the curvature of demand. It was the elasticity of the marginal surplus, right? So here, there's going to be, again, theta is going to interpolate between these two. So remember that when theta is equal to 0, we have perfect competition. In that case, these terms will drop out, and we get 1 plus the elasticity of demand over elasticity of supply, which is the classic perfectly competitive pass-through formula. When theta is equal to 1, we get 1 plus the elasticity of demand minus 1 over the elasticity of supply plus 1 over the elasticity of marginal surplus. I'll talk about this term in a second. So that's monopoly. This term has to do with how theta changes as the quantity changes. But if we just have straight up monopoly, that won't change at all. But in between, we're going to have some sort of weighted average of these things in the appropriate sense. So we have some weight on the elasticity of marginal surplus, and then we have some value of theta there. And so, Connor, what are going to be what are the key changes that have occurred in this formula versus the monopoly and competition formula?
Well, so one of them is that you now have, for the two terms that were in the monopoly expression, you now have the minus theta and the theta. So like the strength of that effect is increased depending on a denominator.
Yeah.
And you also have the new term.
Yeah.
Reduces pass through because it is always positive.
Well, is it always positive? So think intuitively about this. Remember we said that in the Bertrand model, as prices rise, things are going to get less competitive. What is that going to do?
That'll mean that it suddenly decreases if prices get high enough.
Yeah, so theta is going to decrease if prices get high enough, so that's going to be negative, right?
So then it actually increases pass.
So that it increases pass-through, because the point is that if prices rise, then the goods are less good substitutes for each other. They're competing less intensely, and that's going to lead prices to rise further, right? So that tends to make the pass-through greater relative to what it would be in other models that have the same amount of competition. Okay. So again, we can use this to summarize many problems like the procurement problem, the trade taxation problem. Remember that all those things had very simple things if we just use the incidence and the pass-through formula. So there's lots of policy questions that we can look at just using these formulas. So just to give a sense for this, okay, so under competition, equilibrium is demand is equal to marginal cost, right? Under monopoly, it's marginal revenue equals marginal cost. Now, under some value of theta other than 0 and 1, the marginal revenue is sort of, the relevant marginal revenue is going to be some mixture of demand and cost. And so you're going to get a pass-through rate that's a mixture of what it would be under competition, which is here, what it would be under monopoly, which is here, and the oligopoly one is halfway in between, because the relevant curves that determine it are halfway in between the marginal revenue and the demand curves. And that's the reason why we get this mixture down here. Okay. Now, under deadweight, so what we got was that the marginal deadweight loss from an increase in quantity was smaller under oligopoly than it was under monopoly, right? And intuitively, Jack, why would that be the case?
Basically, in oligopoly, consumers have more options to substitute towards. Instead of monopoly, it's just one seller.
Yeah, so that's exactly right. So what happens is that when the quantity increases under monopoly, consumers can only substitute to the outside good, which has no markup on it. And so you get the full deadweight loss when a consumer stops buying one firm's good of the markup minus 0. But if consumers can instead substitute to goods of other competing firms that have markups on them, then that partially offsets the loss of the consumer not getting the markup on that good. Because now part of the externality is real. When I stop buying this good and now I buy a competitor's good, right? That competitor is gaining a benefit. It's not just, society's not just losing that sale that could have earned that markup. It's now substituting something else that has a positive markup. And so you're having a real externality as well as the externalities on consumers, right? So really, we should be subtracting off from my markup the average markup of goods to which the consumer substitutes, right? Because the real loss when a consumer, from society's perspective, when a consumer fails to buy my good, is not the markup that I'm earning, but the markup minus the markups on all the other goods that they could have bought, right? Weighted by the chance that they would have bought those other goods had they not bought my good, right? So the right or real expression is not m times dq, but m minus m bar, which is the average good that consumers substitute to, the markup on that, times dq. And so why is it theta here? Well, it's a weighted average of, they might substitute to the outside good, in which case you get the full m, or they might substitute to other competitors' good, which I would have the same markup, in which case this should be 0. And that's exactly what 1 minus the diversion ratio does. Right? Okay. So in symmetric oligopoly, of course, this just symmetrically reduces the deadweight loss from each good. And it's captured by theta. But things are more interesting when things are not symmetric. Imagine that some firms have higher markups than other firms. What might happen then, Kevin? Imagine that one firm has a really high markup and another firm has a low markup, but that people might substitute from the low markup firm to the high markup firm.
So this is like no longer symmetric.
Yeah.
Example, you mean?
Yeah.
So you said the example is when
Imagine I have a really low markup, but people are thinking about buying either my good or a good with a very high markup. What could be the case then?
well, there would have to be a reason for you to be able to, or for you not to have a higher markup. So I guess
But let's just take that as given. Just thinking about this formula. Would it be beneficial for me to sell more if I have a positive markup?
yeah, maybe.
But people are substituting away from a firm which has an even higher markup.
Oh, you mean beneficial to society?
Yeah.
Oh no,
Why?
because if you can consider the total surplus, including the other firm. And they would
Yeah.
get more if they got that consumer's markup instead of us because we have a low cost.
Exactly. So it actually could be beneficial for me to produce less, even though I have a positive markup. So we always think that anyone with positive markup, we should have them being producing more, but that's not true. Not if they're substituting away from goods that have higher markup. So if firms have different cost structures or different sophistication about how to price, some are just more naive and they price near their cost, or they have different conjectural parameters, or they have different quality products, they might have different markups. And in that case, it could actually be beneficial for the firms that are less, that have lower markups to actually produce less rather than more. So for example, in a Cournot oligopoly where firms have different costs, the firms that are inefficient and therefore have a low markup will be producing, and it would actually be efficient if you could reallocate that production to the firms that have the higher markup, because those are the more productive firms. If you have low quality goods competing with high quality goods, it could actually be good to tax the low quality goods, to give them more market power so that people substitute away from that good to a higher quality good. If you have people who are, if you have like a market design problem or an auction where there are some naive people who think that they should just bid their value and other people are bidding below their value because they're sophisticated, well, it would actually be beneficial for people to get more savvy and exert more market power, because it would reduce the chance that you ended up with the people who are bidding low getting the good rather than the people who are bidding higher. So an interesting consequence of this is you often hear in market design contexts people saying that people are differently sophisticated in participating in mechanisms, and this could lead the people who are unsophisticated to get screwed. Well, that's kind of true. They are worse off than if they were sophisticated. But the real harm that they're causing is not that they're getting screwed, but that they're actually causing the sophisticated people to get screwed because they're being more competitive and taking more away from them. So their real social harm is not that they're getting in trouble, but that they're harming other people by failing to exert their market power. So it's actually better that we have it's more important that we have homogeneous market power than it is that we have low market power to some extent, right? Okay, so we can now put this in mathematically by imagining every firm has its own markup and its own strategy. And then there's going to be a vector of prices as a function of the vector of quantities. This is like a general equilibrium, which depend on the vector of strategies. And now we can have a more general definition of the conduct parameter for each firm. What is that? Well, that's the sum over all of the firms that if this firm changes its strategy, it's going to affect quantities. And it will affect prices, right? Any firm changing its strategy will affect both quantities and prices. And you multiply that by all of the markups of all the firms whose quantities it affects, and by all of the quantities of all the firms whose prices it affects. And you get a value of the conduct parameter for that individual firm, which is the ratio of its pecuniary to its non-pecuniary effects, right? And again, this is going to be equal to 0 for the planner, 1 for a monopolist, and when not all the firms have the same markup, it's not going to be optimal for me to have 0 markup. You want all of our markups weighted by our quantity effects to cancel. And so if you were thinking about what's sort of perfectly competitive behavior for an individual firm, it is not them setting their price equal to cost. It's actually they're setting their strategy so that their markup, weighted by all the quantities, offsets the markup of all the firms that that are substituted away from. Right? So this says that heterogeneity of market power rather than its level is actually the most important harm. Right? So for example, in Budish's mechanism, strategy is really like market power. So we really, in his mechanism, would want everyone to be equally sophisticated, not for people to just blithely report their preferences. entry into an industry with market power therefore might be excessive, because you might want to come in and act competitive, but that might take away rents from other people, and that could be harmful. Okay. So we can go back to all of the examples that we had from before of different models, but now rather than having rather than having everyone have the same markup, we can have different ones. So under Cournot, it turns out that people's theta is equal to their share in the market. So that's 1 over n if everyone's homogeneous, but it's their share if it's heterogeneous. Under conjectures, there's this formula. Under differentiated products, Nash and prices, it turns out to depend on, it's going to be 1 minus the sum over all the other firms of my diversion from that individual firm times the ratio of our markups. And that means I could actually have a negative conduct parameter. Why is that? Well, if I'm substituting from firms with higher markups than me a lot, that could actually lead this to be greater than 1 and me to have a negative conduct parameter, which means it would be socially beneficial for me to produce less. And a classic example of that is when one firm produces a really low quality good and another firm produces a high quality good, and almost every consumer would substitute first to the low quality good before they substitute out of the market. So people either are buying the high quality good and they're on the margin to buy the low quality good, or they're on the margin between the low quality good and the outside good. Then the low quality good could have a really low price, but there's a lot of substitution coming from the high quality good with a large markup. Then he would actually have a negative conduct parameter, and actually it would make the market more competitive if he charged a higher price. And this is a typical case for sort of copycat goods or inferior goods, which are harmful because even though they offer an alternative that gets more people into the market, they also cause people to stop buying the high quality good, and it might be actually better if they just stop production altogether, because they're causing so many people to substitute out of the high quality good down to them that it could actually be harmful. You can also derive incidence in this context. I won't go through it all, but anyways, you get some formula which now depends on the covariance between how big people are in the market, how much pass-through they have, and how much market power they have. You want, so the firms want the biggest people and the ones with the most pass-through to also have the highest market power. And you can do all of this analyses in this asymmetric context, thinking about what the covariance is between the pass-through rate, the size of the firm, how a given intervention affects these different firms heterogeneously, and their conduct parameter. Okay, thanks guys.